So continuing with our series, that's the question which you found today, and as you can see these are the question from calculus. तो जो पहला क्वेश्चन है वो आपका इंटीग्रेशन पे है और इंटरेस्टिंगली इट्स बेस्ड ऑन इनइक्वालिटीज ऑफ इंटीग्रेशन बच्चों, डेफिनेट इंटीग्रेशन. So first one is given p is equal to, so that's one integral which we are given, and another integral is q. And see, these are the options in such type of question. See, what I will say here is that in such type of question where we have to deal with the inequality related to definite integration. See, indefinite integration inequality is a vast open inequality. What I mean here is that we have to just find two limiting functions. So if fx is a function that lie between two functions h of x and g of x, and we have to integrate them between two limits a to b. So we know using definite integral that integral of f of x from a to b lie between integral of g of x from a to b and integral of h of x from a to b. The point is, why did I say it's a vast open? Because you can find maybe n number of pair of functions between which your function lie. For example, see, if I say sin x, so we know that sin x is, I'm just giving you an example bachcho. If I say sin x, we know that sin x is always less than equal to x, and of course when x is greater than 0. Let's consider it that side. Okay, so and since sin x is between 0 and 1, so and it's positive also, I'm considering on the positive side, so it is always greater than or equal to sin square x. That's what we know. Okay, now you see sin x is less than x and greater than sin square x. So if I say that sin x is less than 2x, won't that be correct? That's also correct. And if I say it's greater than equal to sin cube x, won't that be correct? Because you go on increasing the power, the value goes on decreasing. Why? Because sin x is between 0 and 1. So if you have a number between 0 and 1 and the power increases, the value goes down. My point is simple, that you can find such n type of combinations between which your function lie. And then when you will integrate, you integrate this between any two limit a to b, you will get some different value. You integrate this between a to b, you will get some different value. Similarly on the left side also. My point is simple, that when we are trying to evaluate such integral and when we have options in front of us, we work accordingly. Like, see, for both, in both the options for q, it is compared with ln2, one thing. In both the options for p, it is compared with root 2 minus 1 by root 2. Okay, so what does that mean? See, and limit of for p is 0 to pi by 4. Cos root pi by 4 is 1 by root 2, or sin pi by 4 is 1 by root 2. So that means here we will try to retain sin or cos. Be very clear about it. Similarly, if I am talking about ln and we have tan, see, whose integral gives us ln? So integral of tan is ln sec x, integral of cot is ln sin x. So in both tan and cot, when we integrate, we get ln. So while using it, now what are we going to do? So let me start. See, we are given that p is nothing but 0 to pi by 4, and the integral is sine of tan x with respect to x. So it's sine of tan x with respect to x. So here I am very clear that I am going to retain sine, because when sine is being integrated, it will give cos, and cos pi by 4 will give me 1 by root 2, and I know I need root 2 in denominator. Okay, so now see, between 0 to pi by 4, so it's positive and it's less than, it's between 0 to pi by 2, and from 0 to pi by 2 we know that tan x is greater than x for all x in the interval 0 to pi by 2. All of you will agree with that, isn't that? Now what about sine function? Sine function is an increasing function in the interval 0 to pi by 4. So if we impose or take sine both the sides, since it is an increasing function, the inequality sign will remain as it is. All of you agree? Since sine t or sine x is an increasing function, so you can take sine both the side without changing the any inequality sign, retaining the same inequality sign. Okay, so now we have it. So therefore our p is greater than integral from 0 to pi by 4, which is sine x, and this is nothing but, we know it's minus cos x, and 0 to pi by 4, which is 1 minus 1 by root 2. So therefore it's quite clear that p is greater than root 2 minus 1 by root 2, and I hope we have an option there. So root 2 minus 1 by root 2, so that's the correct option here. Now similarly use it for q. Q is tan of sine x between 0 to pi by 3. So q is, just a minute. Okay, so let me get some space here. Okay, so now q is 0 to pi by 3 tan of sine x bachcho. Okay, so now what? So now what we will do is, it's 0 to pi by 3, and let me write it a bit clearly here. So tan of sine x, 0 to pi by 3. Okay, now we will start with sine. Now sine x is less than x. Okay, for all x greater than 0, and since our integrals limit is between 0 to pi by 3, so x is positive, no big deal. Now tan x is again an increasing function in the interval 0 to pi by 3, so I can take tan both the side without bringing any change in the inequality sign, so I can write it. And then if I integrate it, so if I integrate it from 0 to pi by 3, so it is less than 0 to pi by 3. So what does that mean? That means q is less than integral 0 to pi by 3 tan x. See, that's what I said. Now tan x will give us ln. So it is nothing but ln of sec x, as x goes from 0 to pi by 3, and sec pi by 3 is 2, so it's ln 2, and sec 0 is 1, so that's gone. So it is less than ln 2. So that's the question. Okay, so my point here is that in such type of integral, definite integral question where you have to use inequality, which inequality are we going to use will be mostly decided by the options in front of us. Okay, so that was my point here. So that's how we can solve this question here, bachcho.